Good morning, guys. The last Saturday of the year 2019. So I know it's vacation time, and I really appreciate that you guys have joined in to attend this webinar. Thank you so much. So, right now, first of all, we're going to see what Industrial Revolution was all about, what it is. Then, what is Industry Revolution 4.0? The different technologies which are there in Industry 4.0. And then I'm just going to explain you in very short that what is blockchain technology and how blockchain has evolved from being a mere cryptocurrency to a technology that is able to provide you with enterprise solutions. And then the last part for the day is blockchain plus industry 4.0. I'm just going to state it as a very high level overview about the different characteristics that blockchain technology has. Basically, the different offerings that blockchain technology is providing to the various technologies in Industry 4.0. And in part two, we will be covering this in depth. Basically, in part two, we'll be seeing the different challenges that the technologies in 4.0 is facing at the moment and how blockchain can help to overcome those challenges. So basically the intent of blockchain technology in industry 4.0 is to become a catalyst of trust building. We will see how as we go ahead. Okay. So talking about industrial revolution. So industrial revolution back in the 19th century. Before that, it was all about manual labor. There were no machines. So steam engine was invented and thus machines came into existence. And that was Industrial Revolution 1.0. The Industrial Revolution is all about how to make human lives better, and it is closely associated with the manufacturing industry. So in the first revolution, that is Industry 1.0, steam engine was invented, because of which there were machines which worked on, machines came into existence, thus reducing human labor and providing more efficiency and productivity. Basically, look, the revolution aspect is associated with growth, how an industry grows. An industry grows with productivity, not just the volume of the production and the consumption. Basically, if you're productive with your approach, that is lesser investment, more outputs, more returns, more profitability, more growth, more consumption. You're efficient with your manufacturing process. So the Revolution 2.0, there was the electricity, the invention. When there was some new invention with basically a disruptive technology that comes in, there was a revolution in the industry. So electricity came into existence, and that was Industrial Revolution 2.0, because of which there was mass production and assembly lines were able to be placed, which boost manufacturing, basically boosting the volume, the consumption, and enhancing the growth. But still, there was a lag. Like human lives did become better, but there was still some efficiency lag. So Industry 3.0 came into picture when there were computers were invented. Basically, lot of efforts that was done by humans. Now computers were able to perform those tasks, but there were manual basically there was an interface where the human had to interact with the computers to get the work done. But internet was there, so that was Industrial Revolution 3.0. So human lives became more better, manufacturing improved, basically productivity increased, and hence the growth of industries. But when it comes to Industry 4.0, it's something different. Now, as per World Economic Forum, today's fourth industrial revolution, it's all about digitization and automation, is affecting the very essence of our human experience and transforming the business models of each and every industry and coming up with more new different kinds of business models as well. Now, every technology that came into existence made the current business model more efficient. The business model evolved. But with internet, there were different kinds of business models which evolved, which came into existence. So with 4.0, it is not just making human lives better, but the experience better as well. So, Industry 4.0 is the information intensive transformation of manufacturing in a connected environment of data, people, processes, services, systems, and IoT enabled industrial assets with the generation, leverage, and utilization of actionable information as a way and means to realize smart industry and ecosystem of industrial innovation and collaboration. Basically, with Industry 4.0, what happened was first, it was production intensive. Okay, that means you had to produce more production, more growth, more consumption. There was not much importance given to the data generated at each step of the supply chain or at the manufacturing stage. The data, which was very valuable to make certain business decisions, which were very critical. Okay, with Industry 4.0, the transformation was not focused on the volume. The transformation was not focused on how machines produced, but the productivity, but the optimization of their efforts. It was more towards the predictive nature rather than the corrective nature, rather than referring to the historical records and then taking a decision with the help of the technologies which is there in Industry 4.0, there can be an analysis done on the current trend and the future can be predicted about which method or which implementation should be done to get the maximum output. And that's what happens what is happening in Industry 4.0. So it is information intensive. It is not just related to how things are produced or made. It's about how the information generated at every step is utilized and put forth to making accurate decisions. So as you can see, first the information, it was just operational reports. Like you just question what is happening, what has happened. Okay, what's happening right now is just you get reports about whatever is happening at the moment. And then in the manufacturing, like what's happening with your manufacturing warehouse or whatever, what's happening in the business right now, get reports. And if something wrong happens, what had happened, you have to analyze it. But the way we are going towards, or the way the world is adopting to Industry 4.0, it's becoming more diagnostic analytics. Why did it happen? We need to know the reason why did it happen so that we are able to prevent it in the future. That's what the value of information is, that you are able to get you're able to get data from every step of the manufacturing process till the time it is consumed, your product or service. And then you're able, if something goes wrong, you're able to ask why did it happen. And if that question is able to be answered, then yes, what is going to happen, you're able to predict and take decisions as per that, align your methods, implementations, process, everything as per that, so that you don't face the same issue again. And that's actually going towards productivity. Now for, look, industry is all about growth, right? So the best example for this is, the first thing was, let's outsource the production where it is cheaper, China and India. You saw a BPO boom, right? And that was like outsourcing for US. Like if the industry is set up here, just an example, the resource is cheaper, right? So this did provide growth, but it was temporary because the resources became expensive after a certain duration of time. And then there was a method that, okay, let's make our factories big so that we are able to produce more, because it's always considered like this traditionally, that more the volume, more the consumption, more the growth. But it happened that there was overstocking of the products which were manufactured because the end consumption was not able to be analyzed. There was no information with that. So If that's the case, then that was also a temporary fix, that you make the factories big, you make your manufacturing capabilities big. No, that was temporary. So something had to be done, and that's why I was emphasizing on this. Industry 4.0 technologies are focused on productivity, about what efforts, how it should be done to get the maximum output. Thus, optimizing the process, basically. Going ahead, let's see the different technologies which are there. Industry 4.0. Now, as you see, it's a transformation of information intensive processes that is happening. Like, it's all about the information generated with every step. Take that information, collect that information, process those information, and get those information executed to get some outputs. That is what Industry 4.0 is all about. So if I state it, it is about that we are approaching a smart factory model where everything can execute by itself by the interaction between different technologies which are attached to different applications in a particular industrial ecosystem, which are communicating with each other, right? So it sounds too good, but it is complicated. And it's not just a futuristic thing, it is happening. These things are being implemented. Okay. So I'll take some of the technologies which are there just to give you an overview about what is cloud and edge computing, what is integration system, what is simulation software, additive manufacturing, big data, augmented and virtual reality, and everything. These are the technologies which are there. These are the prominent technologies which are there in Industry 4.0. As I told you, Industrial Revolution is all about the different technologies which were born in different timelines, which enhanced human. First of all, it made human lives better. Now it's making human lives more, the experience better, making it more efficient, making it more optimal, and hence the productivity increases, hence the growth. So cloud and edge computing. Now, what's cloud and edge computing? Cloud computing, everyone knows that there is a centralized server where all the data is stored and the processing takes place, and there are different machines which can access the data from the centralized storage. Now, what is edge computing? Now, what happens in edge computing is, look, everyone knows that it's all about IIoT. Basically, when it comes, it's IoT, but when it comes to Industrial Revolution 4.0, it's called as Industry Information Internet of Things. That's IIoT. Okay. Now, these are not isolated technologies which work on their own, but they are actually a complementing or a supplementary technologies to each other. They interact with each other because of the applications of those technologies. No, so IoT is all about sensors collecting data, right? Now the sensors collecting data have to execute certain process as per the data that they have collected. They have to take certain decisions. Now these sensors are collecting a huge volume of data. There's a lot of volume of data. There's a mass. Now there is a paper that I read. I don't remember the name of the person, but it's like gravity. It is true. I'm not just saying like that. Okay. So it's like gravity. The more the data is there, the more gravity, the more force it will exert on the application. There will be a latency in which how the transfer is done. Yes, it can happen. I'm not saying it doesn't happen right now, but there is a latency of some milliseconds. But we are talking about IoT, we are talking about sensors, and we are even talking about, if you see, healthcare. We're talking about that the decisions have to be made real time. If the decisions have to be made real time, the processing has to take place not at a cloud storage, but where the sensors are there. And that's what's called edge computing. Because sensors are the edge of the network. So the processing of that information has to take place where the sensors are placed and not at the cloud storage. Because if you want it to be real time, accurate, efficient, and no latency at all, because this data that has been collected by the sensors and the processing that they do on the data leads to a decision that has to be made, and those decisions are very critical and there cannot be any latency which can be expected. So yes, that is what cloud and edge computing is all about. That is how data is stored and processed, and since it's all sensors scattered all over the place collecting data, it's important to have edge computing. Now let's talk about the integration part, the integration systems. Now, industries follow two types of integration systems. You have horizontal integrations and you have a vertical integration. Now, what is a horizontal integration? Now, look, every industry's goal is to grow, right? That is to make everything optimal. To make everything optimal, everything has to be integrated in a very seamless manner. That's what's necessary. And that's what the horizontal integration is all about. The horizontal integration is like the different entities which are there in the supply chain, in the manufacturing chain, have to be connected with each other in a very seamless manner. So basically, it starts with research and development, has to be well connected with the production phase. That is where the product is developed, and then the product has to be shipped. That means the logistics comes into picture. Once the logistics comes into picture, there is distribution of those products till the consumption. So basically, it starts with suppliers and other parties which are there for your raw materials. Then it goes to the development phase where you do the research, the proof of concept, the prototype, and then you go into the production phase where you have to plan, where you are making the actual product. And then after the product has been made, then it goes to the logistic part where and then it comes to distribution. After distribution, it goes to the consumer. So this, if you see, is like a horizontal one after the other. If you see from left to right, it's like a horizontal integration which is there. It's like a horizontal flow. And there are systems which help this horizontal flow to get connected and be integrated with each other is what supports this technology. When it comes to the vertical integration, you're talking about the field level data that has been generated, that is the sensors and everything. Then the control level, that the data that has been generated has to be executed through a program. Then you go to the production level, operation level, and coming to the ERP level. That is how it is like a vertical flow towards the top to the ERP, from the field to the ERP. Then we come, then the simulation softwares which are there, which is very cost efficient, which is a very good method for cost effective production of machines or anything that has to be made in real life, but it's expensive to make it and then test it, rather than you can have a simulation. That is it, you can have it in a software. You can have a software that can develop a real life, how a particular machine, basically a car engine, how it's going to work in real life. You can design it on your in the system itself, test it with real life scenarios and get the results, so that when you start with the real production, the real development, you have a lot of data that you can be considered that you can consider. Now, when you talk about additive manufacturing, now additive manufacturing is nothing but the 3D printing thing that we know about. Basically, the best example that I would take right now is the benefit of additive manufacturing is an aircraft's fuel nozzle. Before, the aircraft fuel nozzle was comprised of 18 different parts which has to be manufactured separately, and then they had to be put together. Basically, you have to put all those 18 products. First of all, you had to manufacture those 18 products different, like every product was manufactured differently, and then you had to put it together so that the fuel nozzle was made. So that was a lot of pain. And with the help of 3D printing, they were able to come to just one component, and they were able to make the entire fuel nozzle as one component and not 18 components coming together. The benefit of additive manufacturing. Big data, there's a lot of big chunk of data is being generated. Like, I'm not talking big data, like basically there's a lot of amount of data which is generated everywhere in the industry at every point of contact. Now that data has to be stored properly, has to be used properly for predictive analysis, and that is what big data is all about. Augmented and virtual reality, something that amazes me a lot. Virtual reality, as we know, is it's like mostly it's been used for gaming and everything, but yes, it has an industrial implication as well, because when it comes to like medical industry, or when it comes to training the employees, virtual reality can be used, and it is being used for the training purposes rather than taking them to the real scenario, like which can be expensive. You can actually show them that, this is how things work based on the real life data that's being captured and processed. Augmented reality is used when it comes to maintenance. Basically, just imagine, you're in your field of vision. When you are looking at a machine, you are about to do some repairs to the machine, and in the field of vision you can actually see the different steps that you're supposed to follow, or the scanning can be done and the different problems can be shown to you in real time, that this is what's wrong with the particular machine. How beautiful that is, how efficient that is, hence it's improving the productivity level. Then robots and AGVs, that is autonomous ground vehicles, which actually is very interesting because you have forklifts and cranes which can work on their own. You don't have to do anything with that. They follow basically, it's like an automated guided vehicle for a mobile robot that follows a marker or wires or some laser and places the things, which is very efficient, that you don't need human intervention because robots don't get tired. And yes, it is effective, it's productive, you're optimal, and you grow. Cybersecurity is an aspect which is embedded into everything, all the technologies which are there, because yes, we are dealing with critical data, so it has to be secure. Then we'll talk about the cyber physical spaces. I told you these technologies are not isolated technologies, but it is a big interaction between different technologies together because of the applications like smart logistics, smart utilities, smart mobility, smart buildings, and everything. How they interact with each other, which technology they are using. So there's a lot of interaction which takes place. Okay. Now just keep this in mind, and I'll just take you ahead with what is blockchain first. So, blockchain is a distributed ledger shared across a peer to peer computing network. Each computer node in the network holds a copy of the ledger, so there is no single point of failure. Every piece of information is mathematically encrypted and added as a new block to the chain of historical records. Various consensus mechanisms are used to validate a new block with other participants before it can be added to the chain. Now, this prevents malicious actions without requiring a central authority. Okay. Any data transfer that happens in blockchain is considered to be a transaction. Okay. So when there is a transaction, first of all, it is a decentralized network. It doesn't have a central entity to take care of any of the process related to the ecosystem. So if there is a transaction, first it is broadcasted to the entire network. The entire network consists of many peers which are there. Okay. Now these peers validate the transaction as per certain rules they have to follow. And there are certain peers which put all these transactions in a set called a block, okay, within a given timeline. And then they do some process to that block to create a validity process, attribute. And again, back to the network, the block is validated by the participants in the network and they are added to their particular ledger. That is the record keeping. That's what blockchain is all about. And the transaction complete. Now, what you see here is that whatever happens in that particular network is visible to all, transparency, right? Now blockchain's inherent capabilities is that it offers you with immutability, it offers you with disintermediation, it offers you with trust, it offers you with decentralization. First of all, it is decentralized because it doesn't follow a centralized architecture. Basically there are peers which are connected to each other, peer-to-peer computing network. And then immutable. Its inherent capability is like this, that you cannot do CERD operations on the record stored on blockchain. That is create, update, read, delete. On blockchain, you can just append and read an n number of times. So basically, you are not able to go and modify any previous data or tamper with it. And then there is something called as a smart contract. Now, smart contracts are self-executing contracts. Once you have deployed, look, if the records can be immutable, the program can also be immutable. And once the program has been deployed, it cannot be even muted by even the author. So what happens is when businesses interact with each other, there's a lot of contracts and policies which are written. Now, those contracts and policies are written by certain legal bodies and they have to take care of it when something wrong happens. So there is a corrective mechanism. And as I told you, Industry 4.0 is all about interaction between different entities, different devices, lot of information exchange, lot of entities connected with each other, a lot of business model integrated with each other. Now, for the ethical aspect of it, how things should go, or the governance policy of it, how what things has to be done, has to be done in a very immutable way. It has to be done in such a way that the contract should not be just paper. It should be a program code which is embedded into that ecosystem itself, reducing your dependency on such intermediaries for interaction. In short, it provides you with trust. Because as you see here, every transaction that is made in a particular ecosystem is shown to the concerned entities. They have to validate whether this transaction is right or wrong. And then it is put into a block, and block is nothing but a data structure. And with the help of hashing, you're able to create an immutable data structure. You put it into a ledger, which is actually a chain of historical records. And there is a consensus mechanism which is followed, because of which you consensus mechanism is basically that everyone in the network agrees to a particular record being valid, and you don't require a central authority. So basically you are not vulnerable to a central point of failure. So let me just quickly run through how blockchain evolved. Blockchain evolved in three phases: 1.0, 2.0, and 3.0. Now, the 1.0, as everyone knows, it's all about cryptocurrency and everything, right? So 1.0 came into existence because of the Bitcoin. Okay. So what happened in 2.0 was Ethereum happened. Basically, smart contracts came into existence. Basically, you were able to develop applications on blockchain technology, not just do transactions. In 3.0, what happened was it became more industry specific. That is, it had to cater to what the industry requirements were. You cannot just have a public network has Bitcoin or Ethereum. When it comes to an industry, it had to be a private network. If it has to be a private network, the architecture is different. The components are different. How they interact is different. And all that happened in 3.0. So blockchain plus industry 4.0, just a little overview of that. And in part two, we will take it in depth. Whatever technologies which are there has to deal with data, and blockchain is a technology that can provide security to the data, basically integrity to the data. If it is providing you with security, integrity, basically providing you with the trust that you don't have to trust the entity of the interaction. You can trust the technology which is helping you store the data, exchange the data, even do payments, because of its first use case itself, that it was able to do transaction. Bitcoin was successful. It was able to do transactions. So just an example, the machines are able to pay to each other because of blockchain technology, which is so beautiful that you don't need intermediaries in between. So what happens is all these technologies, applications like smart logistics, smart cities, smart objects, everything has to go through a centralized cloud. So they are not well connected with each other. The technology is amazing, but the connecting factor which is there, that how this data is exchanged, how this data is stored, processed, it doesn't match up with what the exact applications are. Because if you see, the nature of the application itself is decentralized. Everything is distributed, everything is decentralized, it is scattered all over the place, it's fragmented. And you need something which can handle decentralization, and that is blockchain technology. That will help achieve the vision of smart factories. It is happening, but blockchain will add a trust factor. Basically, it will become a catalyst for trust building. Because trust is something that is a big challenge when it comes to the adoption. And if you have a technology which can provide you with the trust, then the adoption level will go up. Basically, these technologies will evolve. More applications will be built. Business models will become matured. More productivity with the manufacturing, and more optimization with all the methods which are used. So in part two, we will see the current challenges which are there with Industry 4.0 technologies. The blockchain integration aspect, basically, what is the challenge in, if I have to put it in cyber physical spaces? What's the challenge in IIoT? What's the challenge in edge computing? Every technology that we saw earlier, what are the challenges that these technologies have when they have to interact with each other when it comes to the trust aspect? And how the integration of blockchain can help to build trust. The benefits, not just about trust, talking about the ROI, return on investments. If you're implementing such a solution, what are the benefits that you get as a industry? Yeah, obviously, it is also a maturing technology, blockchain in itself. It's evolving, it's adapting to the different things that's happening. So there are certain adoption challenges that also we will be that I'll be discussing it in the part two, and thus concluding the series of in the blockchain industry 4.0 next Saturday, and we can have a question and answer session after that. So thank you, everyone. You can visit our website, snapper.tech. Basically, Snapper Future Tech is a blockchain development company, and it has two brands, Snapper Bus, which is all about the latest things. If you want to stay updated about whatever is happening in the blockchain space, please come to snapperbus.com. And we have a training wing that is the Indian Blockchain Institute.com. You can go there and see the various modules and programs that we are offering. Just putting it forth, the Indian Blockchain Institute development, the portal is under development, and we'll be launching. Basically, we are revamping it to make it a very seamless experience for everyone, and it will be going live by first week of January. I'll be updating everyone. You can connect with us on info at indianblockchaininstitute.com. Please follow us on Instagram at Indian Blockchain Institute. Thank you so much. Wishing everyone a happy new year. Happy vacations. Take care.